Linear regression. Instructions for finding regressions on the TI Nspire calculator. So this is how you would find a linear regression with the calculators of the class. And then here's how you find regressions on Desmos. You can also refer to the video from before that goes over correlation coefficients for the Desmos. Alright, let's look at the first example here. Cat age in weeks and cat length in inches. So let's go ahead and put this data in on the TI Nspire this time. So when we go to the TI Nspire, you want to go to the home screen and then click on the green beaker, Vernier Data Quest. You'll click the table and then put your values in. And then just keep putting them in until you have all of them put in, and then you'll do the next step. Alright, so next step is to click the graph at the bottom. You have to click this graph for the menu to actually pop up correctly. So you go Menu, Analyze, Curve Fit, and then we're going to do Linear. So don't press OK until you're done with writing this stuff down. Scroll down, and then you'll see the M and the B and the correlation coefficient. Record those on your paper. Alright, so we've recorded our data, and we rounded it. Using the equation, predict the length when the cat is 10 weeks old. So, X is representing the cat age, and then Y is representing the length. So let's go ahead and plug that into the calculator. So 0.6 times 10 plus 13.67. And that's 19.67 inches. Alright, let's do 20 weeks old now. So press up, enter, and then now you can edit the expression you typed in. So 20 weeks old is 25.67 inches. 35 weeks old would be 34.67. And then for 100 weeks old with the model, we would have 73.67 inches. Alright, so if we look at this, 100 weeks old, the cat will be 73.67 inches. Now that would not be reasonable. Why it's not reasonable is because when a cat reaches a certain age, they'll stop growing. A typical cat. Now there is a disorder that a living creature will keep growing forever. But normally those, even then, there is a limit somewhere. Whether it be by age or genetics, there will be a limit for any kind of realistic model. And then the last question is, how many weeks old would a 30-inch kitten be? Let's type this one in using NSolve. To do that, we press Menu, 3 Algebra, 1 Numerical Solve. Type in the equation. 30 equals your formula, 0.06 x plus 13.67 and comma x. And there's your solution, 27.22 weeks. So a kitten that is 30 inches will be approximately 27 weeks old. When you're doing the other example on your own, to clear out the data from the Vernier Data Quest, if you notice if you click on it again, the data will still be there. If you want to get rid of this, what you want to press is Control W and then No. That way when you click on for new data quest, the data will be empty again. So again, you press Control, W, no, and that clears out all the tabs. So again, go ahead and do number 2 using that the TI Nspire still. You can also use Desmos if you do not have a calculator next to you. Let's look at the next page for determination coefficients, R squared. With these, you can determine if a correlation is strong or weak. Now, quadratic regressions will not have a correlation coefficient, and they only have determination coefficients. So when selecting models that are not linear exponential, you may use this instead, but also use other context clues from what your real life situation is about to select the best model. So if we have a determination coefficient of 0.99, that is strong. The closer it is to 1, the stronger it is. The further away, the closer to 0, the weaker it is. So like this one, 0.08, that's weak. Do the rest of these on this page.